Okay, this is Unit 5, Day 15 notes. Starts on page 41 of your packet. And these are going to be short notes. We're really just doing some preparatory work for an activity we'll be doing in class. So you're going to need your activity paper. That's that sheet that has the half-inch grid on it, scissors, and some tape. And so this class will focus on modeling and optimization. And the essential question is, how can derivatives be used to maximize and minimize values? So what you're going to do is you're going to be preparing your activity so that we can use class time to analyze data. So you should have a grid. It looks like this. It's a 10-inch by 12-inch grid. It should be cut out of that paper that you have. And then this grid is a half-inch grid. So every one of these boxes is a half-inch by a half-inch. And what you're going to do is you're going to cut out the corners according to what I've assigned to you. And so I have a random cutout here of a square cutout of each corner. If you're assigned let me just back up here. If you're assigned a 1 by 1 cutout, that means you're cutting out one square of each corner. If you're assigned a 2 by 2, that means you're cutting out a 2 by 2. In other words, a total of 4 squares in each corner. 3 by 3 is cutting out a 3 by 3 pattern in each corner, and so on and so forth. So a 1 by 1 would be a half-inch by a half-inch. A 2 by 2 would be an inch by an inch. A 3 by 3 would be 1.5 by 1.5 inches, and so on and so forth. So you're going to cut out those corners according to what I've assigned to you. And you have to specifically do what I have assigned. I've assigned a pattern for you, and there's somebody else in the class that has the same pattern so that you can collaborate with another person. So you cut out the corners, and then you're going to fold up the flaps to make the sides. So these flaps here, there's 4 of them. If you can picture a little dotted line going from corner to corner here, we're going to fold up these 4 flaps. And that's going to make a box that's got an open top. And then we're going to tape the corners. So that's what I would like you to do. So you go ahead and pause the video and do that. As you fold up these flaps, so if you are listening to the video now, I'm assuming you've paused it and folded up and taped your corners. So when you fold up these flaps, then, as this graphic is showing, as you fold up the flaps, you're going to tape the corners right here, and you're going to make this open top box. And so if you notice that where you tape along those corners becomes the height of your box. And we're going to measure that in inches. So your height of your box should either be a half-inch, an inch and a half, 2 inches, 2.5 inches, and so on and so forth. I think we have all the way up to 4 inches of height. And so depending upon what your height is, with whatever is left over, you're going to have a length and a width to your box. So you're going to have to figure out mathematically, according to your height, what your length is and what your width of your box is. And what you're going to do then is you're going to fill in the line on the table in the next screen here. So the fact that we all started with this 10 by 12 inch piece of paper, that's called a constraint. Okay, so a constraint is something that it's like a parameter that everybody has to start with. So we have this constraint as a 10 by 12 inch piece of paper. And then since we all did something a little bit different here in cutting out the corners, we all have different boxes with different dimensions. So what we're going to do then is you're going to find the height of that box. And you're going to find the height of this box and measure along the taped corners. And you really just need to count the boxes. You know that that grid is each a half-inch, so you can just count the boxes and figure out the heights using that grid. That's why that grid is there. And so now that you have your height, then you can figure out your width and your length and get those dimensions in inches. And again, you can count the boxes. You don't really need a ruler. And then you can calculate your volume. Remember, the volume of the box is length times width times height. So what I would like you to do is according to what height you have, get your dimensions, calculate your volume, and fill out your specific row in this table. And then you could even graph your point here. And then when we get into the classroom, we will, at the beginning of class, you will meet with your partner, confirm your data point so that you know it's correct, and then we'll share all the rest of the data with the class. And then we'll proceed to optimize do an optimizing question on our activity. And so our optimizing question is, what height do we need to maximize the volume of this box? So when we get back into the classroom, we'll go over the takeaways and we'll continue with that investigation.